I want to talk about a bit about readability and why I think it matters. I was listening to the stream on a podcast actually for Handmade Network Seattle between Odin's creator and Ginger Bill and Sig's creator Andrew Kelly, and there was also sorry I don't remember his name. Who worked on several compilers, another guy. And the important thing was they were talking about towards the end, like about like the different philosophies between mainly between Zeg and Odin and Ginger Bell is dressing like he made his language so that it should for the joy of programming, so it would feel just right to work in the language. Meanwhile, Zig is, in the words of its own creator, is like about writing correct programs. And actually momentum. Okay. Yeah. Anyway, sorry, I just got something here in this chat. So let me just look at the Sig programming language. It says it's a language and toolchain for maintaining robust, optimal, and reusable software. And the Odin programming language is intended for simplicity, high performance, and built for modern systems and the joy of programming. And Bill seems to stress that part, like the joy of programming. And this is interesting because when I was looking for some alternative to C++ mainly, I guess C++ and C, I was looking at Zig and I was looking at Odin and a bunch of other languages as well, including C2. And C2, as I've mentioned before, it's more of a it calls itself an evolution of C, and it really doesn't try to go like beyond C. But what actually it wasn't as interesting as Odin and Zig because it didn't try to go very far. But something that struck me when I looked at the source code was that I found differences in readability. So I just picked up. Here's the Odin JSON. I find it fairly straightforward actually. It's easy to read. It's I'm not looking at the code qualities as much as like how does the code read. I end up reading a lot of code. I maintain a huge actually code base, not like borderline huge, not that. I've trimmed it down because it's an old system and you have to keep trimming it. But I spend a lot of time reading things because there's a feature, I have to fit it in. How did that piece of code work? And what's important to me is it clear how that code worked, because I now need to know exactly how it worked. So readability is super important, and anything that prevents readability is a big disadvantage. So, okay, before I go too far into that discussion, let me look at Zig. So Zig here, this is not a really fair comparison because they're doing different things. So here we have like this write stream implementation for JSON in Zig, but you can note that this is fairly compact. That has to do with amounts of space people put in, but there's also, like, despite the fact that Sig stresses very explicit code, I find that this type of the way it handles, for example, error codes here, is not super obvious, because you have to learn to read these tries. And some of these are like the switch. They were switch cases. They are turned into these sort of, they are turned into something that looks like structs, right? And then there's this, there's a lot of dots. This one doesn't really have that many. It's like cell stream print. That's fine. But I find, okay, here's an example. So there's always like this standard math, blah, blah, blah. So there are a lot of dots here. And I find myself like really not liking this because there is so much visual, to me, there is so much visual noise. So finding myself here, I would sort of get caught up in okay, there's something here, and there's something, did something, and I have to read this, and they have to read this. I find myself not completely. There's a lot of things to read, and the fact here that there's, like this, there's always this self, there's this self, there's this self all of the time here, and there's several dots. That makes me feel like, okay, I have to look up what's the stream, what is that? That's some other struct. I have to look that up because there is this indirection, these dots all over. And now I want to show you basically the C2 JSON. And now there's no coloring here, but to me this looks like very plain, right? It's there's nothing weird happening. There's a text buffer, which happens to be what there is in the Sig example. That's self, right? But here it is explicit. Okay, and then we just take something and do something simple, and then maybe there's nothing here that I wouldn't expect to see in C, right? It's fairly straightforward, just C, and I don't feel what is happening here, and here is doing some clever stuff. There is nothing clever, but there are also no huge amounts of dots. Here we are working on the node buffer, and we just use this data and whatever. So to me this looks very straightforward and simple. A lot of this comes from, of course, that I've used C a lot, right, and C++, and it's familiar, and that is not something to say, okay, because you haven't gotten used to the Sig way, that's why you have problems. But getting used to something is a problem in itself, because often, at least for me, I jump between a lot of languages. So when I read things, I want to be able to sort of pattern match. Okay, this looks weird, this looks odd. So there are pieces that like things that are bad are when things look similar, but they mean something very different. If your syntax is something that it looks similar but it doesn't mean the same thing, then it will confuse me. If I have two different languages and they do very similar but different, then that's also something that is difficult to get used to. Like jumping back and forth, that's sort of annoying because you have to switch your mental model a bit. And speaking of clarity, I think that it's not very. It feels clever that you're able to express a lot of things, on a line or whatever. But it's not clever if there's, you have to cram a lot of information into that line. That just makes it more difficult to read because you still have to sort of parse every single piece of code. So C in that regard, C is pretty simple because, when you do C code, it is, you just have these very standard tools. You have the functions, you have the struct unions, and you have your variables, and that's pretty much it. what makes C a bit bad in terms of readability is when you have to do a lot of things that are boilerplate but not important. So maybe I'm writing some code that are doing things, maybe it's checking something. So we have like 3 or 4 or 5 checks. Let's say we have 5 checks. So it's one line, do this and check, do this and check, then do this and check. So if they are might be like, when I see 5 lines of code and each of those are checks, then I feel like these are probably equally important for me to check. But if there are some lines, like some checks that have more code, I feel like, okay, this is a more complicated check. But sometimes for C, because strings, for example, are pretty rudimentary, so you have to have a few helper lines. Maybe you define your buffer and then you do some string copy here, la la la, and then you do some free. So you might get, like, instead of 1 line, maybe there are 5 lines and 4 of them are just helping setting things up. It's not that that is difficult or hard to read, because usually that's pretty straightforward, but that sort of adds a few lines that you have to scan, right? And that also makes you sort of, will read those lines more than the rest. So it's easy to lose track of things. So that is one thing that I think is bad about C, when it like has more things. You have to do more things than the situation actually warrants, right? So that also happens like when you have for example, you have an array and you have the length, and the length is separate, like it is in C, and then you have to maybe do the checks, different lines, and there are, and it just might have some call just to get the length right or something. So you add a line instead of just asking like for the length that you would do in most other languages. And this also sort of brings me into another thing, which is, recently I've been looking into the syntax of C3. So I end up, I have, let me just pick a screen and show a bit. So this is CI on, hang on, I'll switch the screens. Right, takes a little while with Twitch here. So let's see here. I have so many screens. Okay, there we are. So I'll hopefully switch to that one. So you should see the screen. So currently, in order to, if you have a function, you have a struct for example, so it's called, foo, which all important structs are called, and you have an element A and a double, maybe D. Okay. So, and you have some test function here, and so you've defined your foo. Maybe it's like that. And then you want to reassign it for some reason. And so you can, right now, you can do like this. So you just do, for example, like that. That would create a new one. That would just have the A elements that you do. And the other one would be zeroed out. So this is the same as doing this. Okay. Nothing strange here, but there is a problem with this in terms of readability, because if you have some other line that says A equals 2, like if you scan this, like there's an equal sign here and an equal sign here, and you might scan this quickly. Like, do you really realize that in this case, actually I disallow assignment operators, so this could never be an assignment inside of this initialization. But would you realize that when you're scanning? Maybe you don't see this part. You just scan, oh, a equals 2 something. So, well, that makes it difficult. And the old C way of doing like this is actually excellent, because I can never mistake this for being an assignment. There's something weird here, the dot. It doesn't look like an assignment, right? So similarly, I have this problem with named arguments that I still haven't really figured it out. But if I have a call like this, okay, and maybe like this, and we have some default parameters, so like so, then I'm allowed to do this, some call, and then just, okay, let's just do like this. And now we will call this as if it was some call 3. Oh, sorry, 5. Well, that's a bit boring. Okay, so like this. Okay, so this is what happens. But is this good? Because people are used to, maybe you could do the assignment in there. Again, this is not great. So like now, right now, I'm like sort of experimenting with this syntax. And maybe it could be like, okay, this syntax or this syntax, or even this syntax, right? But what's common, the thing common with these is that they are not. It's not possible to confuse them with that there is some assignment inside, and this is super important, and because if you write code and you want, like Sig, you want robust and reliable code, then you want to be able to read the code and see bugs that are there, right? Like visually be able to see those in code reviews. And maybe if I do like this, some call like b equals 7. Maybe I think that, okay, there's an assignment. Maybe later I actually have a variable b and do something to it. So and maybe I think, okay, so maybe I'll do like this, because I did add zero initialization. That was something I thought about for a long time. Odin has it, Sig doesn't. I was like thinking about it quite a bit, but I have, for various reasons, decided that it's a good idea. But anyway, so maybe you have something like this. So maybe you scan this code and see like, okay, b must be 7, because you don't actually read this part. This you don't read that, and just sort of the way you scan it quickly, looking through a lot of lines of code, maybe you see, okay, b has to be 7, or assume that it's okay, that might be the right value. You think that's the right value, and you don't understand that, okay, wait, it's actually 0. Okay. So I think those are super important considerations actually, and doing things that sort of look similar but aren't, they are dangerous. And I also think like pushing a lot of code into like adding a lot of like blah 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 like this. You have to parse like, okay, this means that this one has this member and that one has this member. Is that right? Do I remember everything, like all these members? Maybe I don't. And then it's just supposed to do some call or whatever. Maybe that's a lucky assign something. So that even if these are just modules, it's a pain to sort of parse. Like the less the better, And I think that's why I ended up picking C2, because C2 was clean like C. And this is also the reason why I don't have generics. So I could easily do the generic the normal generic route. So like, okay, let's do this style of, you know, this would be a normal way of implementing a max function. So you have like max A and max B, and then, you know, you basically return A is like this, right? So why don't I do this for C3? Because this, you know, once you start doing this, and then you start, okay, like maybe I should make sure that, you know, let's add something like require that A is, you know, is comparable, blah 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 blah. Okay, like this, it's not a lot of things, but you know, when you start looking at this, like you try to parse what the heck is this function? Like where is this is the tiny, the important part is here. You want to know the name, but that's sort of hidden. Like try to find it, but compare that to, you know, okay, I write a macro the way it looks in C3. So okay, this is the macro, and I agree that it's super nice to, you know, be able to express these things like that you do here, but it takes so much real estate. Like the visual impact of this makes it really hard to see, like, okay, this is a max function, right? Because it could be anything. It just happens to here, you can sort of figure it out. But what if it's called like futsvur? Like this, like something, you know, really obscure. Like what the heck is that? Or, I mean, even this, just like max could be something in here, like, okay, and B max is blah, blah, blah. There could be something in here. So if you visually scan this, when you visually scan something, what you typically do is like you see maybe this, and you sort of have to, you know, your mind has to fill out the blanks. So maybe you see something like this, okay? So X something, okay, that must be max, right? But if you have something like this, the odds that you actually like see this one is really low. And this gets worse when you have like, okay, I have to parameterize function. So you have some type, like bar, which is an int and maybe it's a pointer to like a baz of a foo of a int, and then it takes like an int here, and I have that one. It's like, okay, is maybe I will initialize that. Like reading this, you know, okay, so people introduce auto just to get rid of that, but this is like, see, there's like, this is pollution, and yes, auto is like trying to sweep that under the rug, you know, just get rid of that for now, and like let's pretend it's, you know, not there. Right now it looks clean here, but you know, maybe you got that from some other function. So maybe you have like some function giving you that. Like what the hell is it? So if you want to be explicit, you have to, you know, write the whole thing. But then you have the problem of it being so darn big. And because if you have something like that, then you want to match that. So you have like, okay, this function takes an int, and then you have to match all this, and that gets like, you get really heavy machinery to do that when you express that as a function, a parameterized function. So you get all this visual noise. And I think, to me personally, this is worse than having, you know, this very bare bones, okay, you have to look up the function or the macro, having some more extra work to get that, create an alias or something. I think it's better to have an alias and make everything easy. Like you could do, like for example, if you were forced to do this, like you couldn't, you know, have the bar. You have to do like this, and then you would have to use like mybar. Okay, suddenly you don't need that auto anymore. Like why do you have that? right? And it's super clear. You don't need this. This is just bad. You just write this. It's cleaner, right? Like here, it's even shorter than this one, right? And you can decide exactly how long you want it to be. Okay, and then you want to know what that is. It's like, okay, it's a blah, 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 whatever. It doesn't matter. That's fine, actually. And because the rest of the code that you are actually reading, I see, okay, there's a my bar and does something. I don't need to know if I don't write. Okay, so then the problem is like if you have something like then go deep, then you obviously have to look at the type definition. Then you have to know everything. But if you don't, if you just use the top level usually, then you just need to know, okay, it's a bar of something. Okay, it's going to be fine. You're going to be fine. You're going to understand the code. So to me, it's like always optimizing for readability. Readability to me is like quick readability. Just not when you like really concentrate on the code that you're working on for a long time. You're really familiar with it. It's about when you sort of scan something. Just you want to write something quickly or read something quickly. What is this about? And I think this is, to me at least, this is more important than anything. The other parts were like joy of programming or things like that, or making everything explicit that Sig tries to do. But that said, so now I've like ranted a lot about this, but this I think also goes back into how you solve problems, like how you, for example, look for bugs. So there was this interesting talk between Sean Barrett and Sean McGrath, I think his name is, and we talk. I think that was the one where they were talking about like different ways of finding bugs, and like I think Sean was saying, Barrett was saying like he would just think about this bug, like how could it happen, and think and reason about it, and then like, okay, this should be like, this is the way it is, and then like after thinking about it for a long time, while Sean was like he would run things through a debugger to sort of see that. I hope that was right. I just hope I didn't misremember. But okay, I think that it was the Sean talk. And I think, I mean, they are great programmers. So it's not that like any of these methods are wrong, but there are different styles. I think something you can sort of learn is that there are very different coding styles, like approaches to coding, that are very valid but still are very different. So I realized that a part of this readability is my personal style. I read a lot of source code. I scan a lot of source code. I jump into code and try to make sense out of it just by reading. And that's not everyone likes to do that. But code is read so many times, and when you want to have someone else understanding your code, I think readability is nevertheless very important. So for C3, readability comes first, and since the language tries to be like a little step beyond what C provides, it tries to improve the readability where C sort of drops the ball a bit. It tries to give you some array tools, for example, that makes it easier to handle those particular cases when you have arrays, which is almost all the time. And that makes it more readable than it would have been without those types. But it's not trying to invent something and do something clever, or do something unfamiliar. And that's going back to what I said in the beginning. You can switch between languages, and a good thing is if the languages you're switching between aren't different in a way that they're sufficiently similar that they feel the same, but they don't quite work the same, and you have to rethink everything. So that is sort of my goal for C3. I might not succeed in doing that, but that I found interesting how there are different approaches. So mine is optimized for readability, and everything else falls into place really. If it's readable, it's usually maintainable as well, because I don't care about how these super high level tools, if the super high level tools also means that it's less readable. Like if you think about it, you can have you have a lot of Java code that is they try to optimize for looking high level. So you get some function that does some just handle. You instantiate some, like on the top level it's like let me just write some fake Java code. It could look like so you have this function like public void start, and you have this function your foo, and you just do like foo run, and that's super clean, right? Or not. And then you have like, and then foo run is actually just like so foo run, then we have like the actual in that class you have like so we have like a public we have some run code that then does like bar init, then bar setup, then bar begin, and then you have to look up these, and they are cascading things to smaller and smaller objects. So there's this tree, could be 5 to 10 levels deep of things, just delegating everything to downwards. And they think that this is readability. This is not readability. This is like the opposite of readability, because if you want to read this, you just go here, then you have to jump here into that one, and then into that one, and then down, 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 and then you go back up this up the stairs, and then down again into the begin, and so on. And these usually have tree-like structures, so nothing is doing anything. And this is like super sucky code. This is like the worst piece of crap you can have, right? Because it's really hard to read, and some of the difficulties in reading client code is like just jumping down, like this is calling this, and this is calling this, and this is calling this, right? But at least those are bounded by maybe four calls deep or something like that, 5. But Java code can be like I shouldn't say like sky's the limit. It's like they can only dig deeper, and people mistake this first like a readability, but this isn't readability. This is just like shoving things further down to someone else, and then there's something like you can't piece it's like a puzzle that you have to pick up the pieces then and flatten it out. So easy to read code can be just like a function after function call. If you have something like if it would look like you have, maybe you do something, and then you do you get something back, and then you do something else, and you can continue doing this for like plenty of rows without this being confusing, because first it does this, and then next thing, and so on. But doing this, like you could do this, but you could do it like recursively in a tree, but not recursively as recursion, like object recursion, right? You have an object that calls an object, it calls an object, it calls an object, and engine, it's sort of still just passing along the request. So readability must not be taken as, simplicity locally. What you want to have is like make a local piece of code readable and understandable. So maybe finally we could sort of have a look at some piece of code, and here it is. Here is a bit of C2 code, right? So we had this on screen before. So here, okay, this is obviously doing something pretty simple. But it's sort of in this isolation, I can understand what it does, right? Because it's like creating something and doing init on these, right? Let's see if I can get something else that is more interesting. So here's a data dump. Okay, so here we calculate something. We don't push this down to some function because we don't need it to yet. And then we print, and then if we're both, then we dump, and the dump would be like a recursive thing, but from the names we know it's dumping something, so we actually don't need to do, go down and see what this does, because the name says what it does. And then we'll see like, okay, here we are on the cursor something here, I think, and then we dump the top node or something, right? So this would make sense, like seeing that in isolation. Now let's pick a bit of picking on Sig a bit. So I mean, Sig is not bad, but let's just put something that is slightly less at duty to me anyway. So like coming from a sort of C level, well, I realize that this is a switch, right? And we have the cases complete, and those are not reachable, but they are. Then we have, okay, the white space, and this has to be some value, and then we have the indent level on the white space, and then this I think is the worst offender, because here's a non-local jump, right? So here is actually something like if this fails, then return error, right? So this is what it means, but the try means that implicitly, and jumping back and forth here, I between languages, I think this is sort of more difficult to read. I also feel that this is like, if it was this, I would feel, okay, at least I have the stream and it's like writing a byte, but it's like self, okay, what is myself? Like, what is the self here? And the self actually is the enclosing type. So I have to go up to the top here, to the very top. Okay, so there's the, like, what is the struct? So it's actually doing this at the top. It looks like this. So this is an anonymous struct that I actually added some state to. So it's like a local environment that they set up. And let me just add some more stuff here so you can see. So this, and then there are plenty of lines, and then this. But this is like pretty clever. You start up and create a small environment that you'll do all these things in. And then these are basically our local variables for just this, this call that sort of are global, but they are local to this function. This is similar to creating a C++ style, where you create a class that has a few variables and member variables, and use those. So this is what this is, right? But so now you have to know what this is, you have to jump up quite a bit, because this is important, because then you have something white space. What is that? So the white space, again, going back to the file, let's see. Okay, so we had that. Sorry, so that was on top here. So again, we have some options, and here we have like this really long things here, right? This is a struct, and in itself. So it's clever to do this, but this also means, like, because this is not here, right? So it could be, out here, for example. So this is like, now I'm whining about stylistic things a bit, but it could be like this, right, as well. So, white space, have something like that, okay? All right, so whatever space. And then we could just access them directly. But because it's not like that, you have to, when you read this code, you have to, okay, let me look up how white spaces looks like. Okay, it's like this, right? Good. Maybe there's some, well, no, these are JSON and special things, so I have to look it up. Stream, I probably know how that works. Then there's this pop state, and now I have to go up and down and see what happens in the pop state, and then we have the indent thing here and the same here. So fairly straightforward, but these actually are doing jumps that are not super evident. I actually have that in C3 as well. There are disadvantages with that. I try to not use this sort of thing, because try means different things. So in this case, it's similar to I think the Rust way, but it's obviously not similar to Java or C++. So this is also something I'm thinking about, when I'm working on C3, that this has worked better. I could go through the error, the way those work in C3 sometime. But let's look at, let me see if I can have the same thing in Odin. I don't know if it's doing the exact same thing here. I would like to have something sort of similar. So looks like doing something a bit different. So because maybe I can't find the print. Oh, here I have something. So the print, here's the print. I'm just going to put that in here. Oops, indentation. So here, I think to me there is less implicit stuff that I need to understand. Okay, we'll go in the case for the map, indent, and then I'll print something. I see this, and there's a lot more code online, obviously, here. But less also, like, okay, we don't see many dots, right? We see fmt, okay, sp print, and I see that all over. But other than that, there's just like variables. So I don't know if this is a good example or not, but I felt like we're going through the Sig code. This is super clever. I think this is clever, but this means there's so much more here. If I have something like that, what does this mean? What's the indent level with the white space? Why is it called that? Like, where is that? And then we have, like, here, it's just the indent is here. Okay, there's a value coming in here. It's 0 by default, and then you store that, and then you do indent. Okay, that I can figure that out. And we have the C2 version. Let me see that as well. So again, so the dump node, here's the one. It's simpler because it's doing less, but here it is. So that one was, this would be C2. And now we're into really simple stuff. You get the node, and then you get the kind, and it tries to, do just a printf, and then do the dump with the indent. So again, here you said there is nothing surprising at all. Possibly this, the names data. So I can, like, there's something deeper here in the node. So I have to look up this node, how it looks like. But this is something I use in the whole thing in the C2 code. So that's probably something I know. But here, I mean, I think this is an offender. Definitely, I would think that this is really bad, doing this stuff like that. And it was clever, but not good for readability. So for the local readability of this basically just destroyed it. Because I can guess what the stream does, but this, I can't know what white space means clearly here. I can guess, maybe it's an indent level, but why put the white space then? It's like, what does it mean? So then we have, we have two settings here, right? We have the indent level that we're using, and then we have like how many spaces each of those indents should be. Sure, fine, but I don't see why it has to be like encapsulated. It doesn't make sense to me. And I see a lot of Sig code like that, so that's too bad. But anyway, so I think that C2 code is the simplest when I'm comparing Sig and C2, because it has less dots, less things that I have to sort of look up and think about and reason about and read and parse, visually parse. So this has been a sort of a long, just random brain dump, but I hope I've explained a bit what I think is important about readability in languages. And we can, I want to add something more. So like a problem with, for example, C++ is, not just the fact that it's a big language, but the fact, because the big language and people are have to use like subsets of it. That means it's very hard to read C++ code, because it might do things that you're completely unprepared to even, think that it could be valid code. Like, is that even true? Like, is this code that I'm looking at, can it even like make sense? While other things like, oh, that's perfectly okay. You can write code in many different ways, and there are a lot of nice, C++ puzzles where you can try to figure out what the code actually does according to the standard. But the simpler the language in terms of syntax, like easier to parse, is also usually easier to visually parse. Fewer things in the language means that there are fewer ways of expressing things, which means when you express something, it's easier to quickly sort of figure out what it means. There's this classic thing which, when you write something like, you start with hello world, like that, and then you remove the vowels, and you can read this anyway, right? Because you can figure out what it was, you can guess. And you could even, do stuff like this, and it works fine. You can, if you know English, you can figure it out. And that it is similar to, like, when you scan something quickly, and then you might just see, okay, you see this, like something world, and you figure out, okay, it's hello world, right? And all this, like if someone would write, instead you would have someone who'd like Jonathan Blow, like hello sailor. Then if you saw hello, just saw this part, then you would know like what is here, what is this part. But if you worked in a where everything was like hello world, then you would know that. So for a more concrete example, if you know like, okay, it's an int I and something happens here, like you're pretty sure that there's going to be some fairly basic, int is some value like 0 and it has some limit and it has some plus either this, or it's going to be like I minus, okay, or if it's C++, it's going to be like this, right? Because they have to do that. But you're going to see that if you see the 4. So you see 4 and something, well, okay, you know what's happening approximately. So the bug is probably not there. So you just skip that line and just go to the next thing. And that is super important when you try to scan for bugs, or if you do code reviews even, you know what can happen here. And there's like this huge offender in C++, and this is something I think is super bad. Super bad is this. So now I have, okay, this is C code. This is C or C++, and this is just C++. So if I am in C and I see super nice X, if this is C, then I know X is the same. So if I do like X equals 1, I know X is 1. But if it's C++, and I call super bad, then X might not be 1. And I can't see that. I can't see that from the context. If I want to do something like the bad thing in C, then I have to be like do something sneaky, like do like this, and then I know, okay, I'm doing something weird here. So X can change, but I don't know that in C++. And it looks so neat, right? You just have the X, right? But it's not good. This is really bad if you want to read the code, because if I just look at a small piece of code and I see like if X equals 1, then do super bad. Okay, so if X is bigger than 2, do something. And I'm like, okay, if I read this in like, if I think C, then I go here into chaos, so I see that super bad happens, because I know super bad happened, right? So then this clearly can't happen. But why does this happen? It doesn't make sense, right? So I'm assuming that I'm, mistaking. Maybe there's some do something later on or something. But this might be modifying your X, and you can see that. But if this had been, you can't really. It's not really sneaky if you do it like this. Now you know, okay, I'm passing this out, and it can't do anything. But you can't see that with C++. These references, don't do them. They are evil. Okay, so yeah, I should quit now. I hope you got something out of this. Maybe I should just look at. There are quite a bit of questions here. So your chat exists. Sorry about that. So what are your thoughts on Go's readability? Good question. I haven't written enough Go to be firmly have a firm opinion. I've just like written like I think one application. I think some things are what bothers me the most about Go is going from Go and C or something else, and then suddenly there's this, the clever way. If all the only language had been Go, it would have been perfect. The way they have uppercase to indicate that this a function is public. I didn't know about that. I was like, why are some? I hadn't read that. I just jumped in, and it's like, why are some of these uppercase like start with uppercase, and some doesn't? It's like the program I wrote just worked anyway, like regardless. But afterwards, obviously, I learned that well that was like public and private. But doing that, like jumping back and forth between like some different code bases can be slightly jarring. Like, okay, I have to look at this code a bit differently, and I think that the some of the ways declarations are not super nice when you go back and forth between languages. So that's my basically I think that Go is a bit too different to be easy to to jump into easily. But Go also doesn't try to be clever, and I really appreciate that. It's like tries not to be clever in the way C doesn't try to be clever. It doesn't try to hide something, but doesn't try to make something things like really wordy either. So I think that's in the sense. I think Go is doing fine. It's good, actually. Despite me having some problems reading Go code because of jumping between different languages and not getting used to it. Are there any questions? Other questions? Or did I answer everything? Maybe I should put that into Q&A, but I don't have that many people here, so maybe, yeah. I'm just going to let go of this, and maybe I can, if I have some questions later on, and maybe I will put this on YouTube, and maybe people will post things and maybe ask elsewhere. Could elaborate on things. Thanks for watching.